Yeah, very good morning to all. This is Dr. Ch.M.V. Hari, Head of the Department of Computer Science from Dr. V.S. Krishna Government Degree College, Commissioner of College Education, Vishakhapatnam. So today I am here to present an operating systems. Okay, I'm very great honor to take this kind of a class. Thank you. Okay, before going to the detailed discussion about operating system topics, okay, first of all, let us glance what we are going to be study in this operating system. So coming to my complete presentation of today is that in the first topic of discussion, what do you mean by an operating system? What is the various definitions of an operating system? What is the main goal of operating system? What are the different types of operating system? That implies what is the need of installing an operating system in your computer system. So what is the main purpose of an operating system in a computer system? That is the first topic what we are going to be seeing in this. And coming to the second topic of discussion is the computer system structure. That implies whenever the user has what is a computer, what are the various components which are there in a computer, how they are interconnected each and every other, that is call it as computer organization, and followed by what is the system operation whenever the user has been switch on a system. So what are the various tasks which is going to be taken by your computer system? Okay, and this is how your computer system is completely functioning. Okay, how a CPU is going to react, what are the events which is fired by all input devices and output devices or from the user. And coming to the next topic of discussion is the operating system structure. So what is operating system structure in a sense? Whenever you want to invent an operating system, what are the various components which are involved? How these particular components are communicate with each and every other is going to be called it as operating system structure. So whenever you want to invent an operating system, what are the major components you need to be considered? Which is nothing but process management, memory management, and that implies what are the various programs we need to write in order to invent an operating system. And the rest of all the topics we're going to be detailedly discuss about operating system structures only. In this, totally we are going to see about four different kinds of topics in detail. Now coming to the first one, process management. So in this process management, okay, we are going to see four subtopics. What is process? What is process scheduling? What is synchronization? And what is deadlock? So first of all, what is a process? What we are going to learn is that what is the difference between a program and a process? And after that, how a program is going to be converted into a process, and followed by okay, what is a process states, and so on up to like this, and scheduling. So what do you mean by scheduling? Your CPU is an extremely fast device. It can having a capability of executing millions of instructions for a small fraction second. But your CPU can having a capability of doing only one job at a time. When multiple jobs are going to be arrived to the CPU at the same time, how can the CPU can decide that which job is going to be serviced first, which is going to be done in scheduling algorithms, and followed by process synchronization. What do you mean by process synchronization? Whenever a data item is going to be shared by multiple processes at the same time, if you're not using any proper security mechanism for the data will going to be enters into inconsistent state. Okay, in order to overcome such kind of an inconsistent state, what are the different kinds of techniques we are going to be uses is going to be called as process synchronization technique. The process synchronization is a set of techniques which can be used to see that the data will not going to be enters into inconsistent state, and followed by deadlocks. What do you mean by deadlock? A deadlock is simply defined as a continuous waiting state of a particular process is known as a deadlock. A continuous waiting state of a particular process is known as deadlock. So we'll see a small definition of another definition of deadlock. Okay, what is a process? And a process is defined as program under execution. In order to execute such kind of a process, it may require several resources like CPU cycles, memory cycles, IO devices, and CPU registers, etc. But all these particular resources are under the control of operating system. So before executing any particular process, first of all, you have to make a requisition to the operating system. I want these resources. Then, so once this resource is available from the operating system, simply it's sanctioned. In case if it is not available, then operating system will put your process in wait state. there may be a chance that this wait state is not going to be changed forever. Hence, it is going to be called as deadlock. Okay. Now, how to handle this? So, whenever this is what is we are going to be seeing in process man, followed by memory management. What is memory management? So, what is a memory? A memory is simply defined as it is a continuous sequence of words, and each and every word is having its own address, which is referred by program counter. So whenever the user is trying to execute any particular program, first of all, the program should be copied into main memory. So how main memory is going to be handled? Okay, in case if the main memory space is sufficient, okay, how to handle the kind of situations? If it is not sufficient, then how to handle such kind of situations? Okay, so such kind of situations, in case if memory space is sufficient, we can handle such kind of situations, no problem. In case if memory space is not sufficient, then we'll go for virtual memory concept. What is virtual memory? A virtual memory is a concept which gives an illusion to the programmer that he has a large amount of main memory, relatively having a small amount of memory. Okay, so such kind of a virtual memory concepts can be implemented by using paging, segmentation, segmentation with paging, and so on, etc., etc. And storage management, followed by storage management. So what do you mean? So whenever the user want to see any particular data permanently, it should be kept it on secondary storage devices. It should be kept it on secondary storage, that is hard disk or a floppy drive, or it may be a CD or something. So whenever you're trying to map any particular data on secondary storage devices, so so how it is going to be managed? Such kind of a topics we are going to be dealt in storage management. In this, we are also going to be seeing about this secondary storage scheduling reports. And whenever multiple jobs are trying to write the data onto the hard disk at the same time, so how operating will going to be schedule the jobs we're going to be seeing secondary storage scheduling report. And the last topic, but not least, which is going to be called as protection and security. How your processes, how your resources are going to be protected from one another. These are the topics what we are going to see in the entire syllabus of GATE 2021. Okay, now we are moving into the first topic of discussion, operating system, definition, goals, and charge. So coming to the first very important one before going to the detailed discussion about okay, detailed discussion about what is an operating system. First of all, let us define what is a computer. A computer is going to be simply defined as it is an electromechanical device. It can having a capability of taking information from the user in the form of human-like language and process that information and gives the output is also in the form of human-like language. A computer is simply defined as it is an electromechanical device which can having a capability of taking information from the user in the form of human-like language and process that information and gives the output is also in the form of human-like language. Okay, now that is what is a basic standard definition of a computer. Now every computer system can be viewed as mainly it is a collection of 4 components. Can you see that information on the screen? Every computer system can be viewed as it is a collection of 4 components. Number 1, hardware. Number 2, operating system. Number 3, application system and application programs. And the fourth one is going to be called it as users. So coming to the first one, hardware. What is a hardware? A hardware is nothing but it is a set of visible and touchable components. What is a hardware? A hardware is simply defined as it is visible and touchable components by the user. That is hardware. Number 2, second very important one is that system and application programs. What is the system and application program? Okay, now your computer can understand only one language, which is going to be called it as machine language. But whatever the programs we are writing, these all programs are in high level language. But your computer cannot understand high level languages. So that you need a translator which must be responsible for converting high level language programs into machine language. Who is that guy? So that is responsible by assemblers, compilers. So what is an assembler? An assembler is going to be simply defined as it takes an assembly language program as an input and converts into machine language. What is a compiler? A compiler is simply defined as which takes a high-level language program as an input and converts into machine language. But internally, a high-level language program is not directly converted into machine language. First of all, it is converted into assembly language, and assembly language, in turn, it is converted into machine language. And the next one, text editor. So this is an environment provided by any kind of an application program to edit your prompt, to enter your program, and followed by database system, etc. It is a computer-based record keeping system. These are all comes under the category of the second component, system and application programs. And the third very important component is that users. So a user is also going to be treated as one of the component of a computer system. Why? Because a computer cannot going to be work as its own. It is always needs and instructions from the user. It is always manipulated by user. These are the three components. Now the latest our focus is on operating system. Now let us define what is an operating system and various definitions of an operating system. And immediately once the topic is finished, I'll tell you what kind of questions we have been got so far in GATE earlier exams. It will going to be discussed at the end of the topics at every topic itself. Now, so what is an operating system? The first definition of an operating system is that operating system is simply acting as an interface between user and the hardware. The first standard definition is that operating system is acting as an interface between hardware and user. That is the first one. What do you mean by what is the difference between use interface and acting as an interface? Interface in the sense without that we cannot do the task. Acting as an interface in the sense without that also you can do the task. Now what is the meaning of this? Is operating system is necessary to run a computer system? So no. Operating system has been invented in 1970s and in 1980s. Operating system has been invented in 1980s. But there are so many programming languages has been already invented. The computer system has been developed in 1950s itself. So without an operating system is also you can run a computer system. That is what we have been seeing in the early systems. So that's why we have been defined as operating system is defined as it is acting as an interface. It is not interface, acting as an interface. Acting as an interface between a user and the hardware. Let us take a small example for this. Suppose you have a vehicle. Suppose you have a some bike. Bike is nothing but it is a collection of hardware components. Now you are the user. In order to drive the scooter, what you require? You require a petrol. That implies that petrol is acting as an interface between a user and the hardware. The petrol is going to be making all the hardware components to work and creating an environment for the user to drive the bike. Is without a petrol, a bike can run? Yes, definitely. Whenever you have an approach, whenever you have it down, you can sit and enjoy the ride. In case when you have an approach, just you push it out. That's enough. This is what is this one? Under that implies what is an operating system? Which is acting as an interface between user and hardware. This is the first definition of this one. And then what is the purpose? We'll see in a little. The second definition of an operating system is that operating system is also acting as an interface between hardware and application programs. What is this? So can we run any application program without an operating system? Yes. So you know that C language has been invented for the purpose of designing Unix operating system. And that implies C language is came before the operating system. Entire operating systems, whatever you are seeing in the market today, these all operating systems has been developed by using basic C language. The language has been invented first and followed by an operating system. That's why we can give a second definition of an operating system is that an operating system is also acting as an interface between hardware and application programs. And coming to the third definition of an operating system is that one program is always runs in the system kernel, which is known as an operating system. So whenever you have been switch on the system, one program is continuously run until your system is turned on. What is that program? That is called as an operating system. Let us take an example. So when you switch on your bike, switch on your bike, so it is going to be produce a sound, something. So that sound will going to be produces until there is a complete continuous flow of petrol to the engine. Otherwise, it simply stops it. In a similar manner, whenever you have been switch on a computer system, one program is always going to be runs in the system kernel, which is known as an operating system. That is the third definition of an operating system. Number 4. So The fourth definition of operating system is that control operating system can be viewed as it is a control program. Operating system can be viewed as it is a control program. That implies what are the set of resources which are there in your computer system. Every resource is under the control of operating system. Okay, so that is first of all, operating system can be viewed as a control program. Okay, suppose if you are moving a bike in very fast, when you want to put a brake on it, what happens is that simply it stops the bike. Okay, this is possible only when there is a flow of engine oil. Otherwise, it cannot going to be stopped. Okay, that implies your petrol is completely controlling the entire operations of your bike. In a similar manner, your operating system will going to be completely controlling each and every peripheral which is there in your computer system. Number two, the second one, operating system can be viewed as it is a resource allocator. It is a resource allocator. So your computer system is a collection of resources. If you want to utilize that particular resources, then definitely you should have an operating system. That's why the fourth standard definition of an operating system is that controlling the resources, allocating the resources are brought together into a single piece of software is known as operating system. Controlling the resources and allocating the resources are brought together into a single piece of software is known as operating system. These are the four most standard definitions of one. What is the main goals of an operating system? What is the main goals of operating system? So why? Okay, number one, the main goal of an operating system is that number one, convenience for the user. Number one is convenience for the user. Number one is convenience for the user. So convenience in the sense, okay, in case if you want, in order to do very flexible use of computer system, you're using operating system. So we'll see in short while how and earlier the people are going to be running the programs. In a short while, we're going to see that how the people are running in early days. Okay, how they are going to be struggled for running a single program. Okay, in order to run a single program, they will take at least 1 week of time just the addition of two numbers. Okay, so what is the struggle? Why operating system alignment? We'll see in a little short while. Now, coming to the first one, the main goal of an operating system is that convenience for the user. Okay, why you are pouring petrol in your bike? In order to make convenience, that implies you want to feel very better. That is the reason why you are pouring a petrol on it. Okay, number two, efficient routing. Your bike is having a collection of resources. Horn, brake, speed, accelerator. There is a lot of features has been already provided. In order to use all these particular features in very efficient manner, okay, then you require petrol. That is going to the main goal of an operating system is that number one, convenience for the user. The user has to be feel very easy to manipulate the operations with the computer and efficient utilization of resources. A computer is a very costly resource. Whatever the set of resources there, in case if you want to use that particular resources in efficient manner, then you require an operating system. Okay, so earlier we got one gate question like this. An operating system is A. It is acting as an interface between user and the hardware. B. It is acting as an interface between hardware and application programs. Number three, controlling the resources and allocating the resources are brought together into a single piece of software is known as operating system. And the D, all of the above. The answer is all of the above. These are the basic standard definitions of an operating system. Now, let us will move to why, how operating system is invented. Okay, earlier days, 1970s and 1975, before how operating, how the people are going to use the computer system, how they are running the program, what are the different kinds of struggles they have been faced in order to run the program, in order to run the program. Now we're going to see. This topic is going to be titled with early systems. This part of the topic is going to be titled with early systems. So first of all, let us see how early systems are there. Early computers were enormously, that implies physically very large machines run from a console. Okay, the programmer who is also having operator of the computer system would write a program and hand over to an operator. Operator will going to run the program. The programmer will not going to run the program. So first of all, let us will define what is early. And early systems are physically very large machines. They has to be run from a console. What is the meaning of this? Okay, what is the meaning of this? In the sense, large means really says that it is the CPU size itself. It is a room size. Okay, so if you want to run a program, okay, at least you need to get a distance of at least 300 to 400 meters distance, and we need to connect a terminal over there. That is terminal in the sense there is no monitors are there. There are only console boards are there. In that boards only the lights are going to be displayed. Okay, depending upon the lights, you need to decode it. Oh, that answer is 5 or 4, something, something. That's enough. So they are an earlier okay. Machines, physically very large machines, they has to be run from a console. There is no monitors are there. Instead of monitors, they have a console display board. At the console display board, it has a collection of lights. Okay, depending on the lights display, so we can decide that whether what is the answer is. That's it. So in earlier days, whenever the user is trying to execute any particular program, so what are the various steps which is going to be taken by the user? And so coming to the first very important one is that whenever the user is trying to execute any particular program, okay, first of all, the user has to write a complete program in machine language on a piece of paper. So first of all, whenever the user is trying to execute any particular program, first of all, the user has to write the entire program in machine language on a piece of paper. After writing this entire program on a piece of paper, the user is responsible for punching that entire program on punched cards. The user is completely responsible for writing the entire program on punched cards. After punching this program on punched cards, okay, so earlier there is no keyboards, there is no monitors are there. So in case if you want to type any particular program, you have to type that particular program on punched cards. After punching that entire program on punched cards, the user is physically responsible for loading the program into main memory through front panel switches. Okay, okay, the user is responsible. First of all, the user is responsible for writing the program. The user is responsible for writing the entire. Okay, the user is responsible for writing the entire program in machine language, and after that, the user is responsible for punching that entire program on punched cards. And after writing that one, the third step, the user is responsible for loading that particular program into memory through front panel switches, through card reader. Okay. And after loading the program, the fourth step is that the user is responsible for setting the starting address of the program to program counter. Okay. In today, this all is going to be done by, okay, very simple, by pressing F9. Okay. By pressing Control R, you are getting all this answer. But earlier, these all activities has to be done by user itself. And earlier, these all activities has to be done by user itself. Okay, that's it. During this particular process, in case if any error is encountered, again you need to start from the beginning. This is how the user is going to run the programs in a stage. Okay, and after some amount of time, okay, after okay, reasonable amount of time, then market we are going to be got assemblers, loaders, linkers, and compilers and libraries has been invented. Okay, now what is an assembler? Okay, so what is, you know that everyone, okay, whenever the user is trying to execute any particular program, first of all, the program should be copied into main memory and starting address should be given to program counter for initiation of execution. Okay, and after that, the CPU is going to be execute the instruction line by line. Earlier, these all activities are going to be done by user itself. Now, once in market, first they have been invented assembler. So what is an assembler? Okay, so people are not feeling very comfort by writing the programs in machine language, that is ones and zeros. The people are writing programs by using simple English language, that is add a comma b like this. Okay, add a comma b like this. This is going to be called as assembly language. This is called as assembly language. But your assembly language programs are not directly understood by your computer system, so that you need a translator which must be responsible for converting assembly language programs into machine language. Who is that guy? And that is assembler. So what is assembler? An assembler is a program which takes your assembly language program as an input and converts into machine language. An assembler is a program which takes an assembly language program as an input and converts into machine language. And after that, okay, so what is a loader? A loader takes this machine language as an input and loads a particular program into main memory and preparing for execution. Preparing for execution in the sense, okay, whatever the program starting address is going to be given to program counter for initiation of execution. And after that, the people are also not feeling very comfort by writing programs in assembly language. Now the people are writing programs in simple English language. Okay, that is then your English language programs is not directly understood by your computer system, so that you need a translator. So what is the translator in the sense? Then they have been invented a compiler. What is a compiler? A compiler takes a high-level language program as an input and converts into machine language. But internally, a high-level language program is not directly converted into machine language. First of all, high-level language program is converted into assembly language, and assembly language program in turn it is going to be converted into machine language. In turn, it is going to be converted into machine language. Okay. And later on, they have been invented linkers and libraries. And that implies whatever the necessary files which is going to be run your program, these all files are going to be attached by your linker from libraries. These are all has been invented. Once these all components has been invented, in order to run a particular program, what are the various actions which is going to be taken by your computer system? Okay, so before early systems we have been seen, okay, before assemblers, loaders, compilers, okay, before inventing, okay, how the user will going to be run the program. Okay, now once these assemblers, loaders, and linkers, these are all invented, then in order to run this particular program, what are the various actions which is going to be taken by user? Now we're going to see. Now these assemblers, loaders, linkers, compilers, these are all are available in tape-wise. In earlier days, these all softwares are going to be available in tape-wise. Now, in order to execute a particular program, okay, so how it is going to be done? First of all, if you want to run a Fortran program, okay, the most famous high-level language program in earlier days, okay, is Fortran. Okay, Fortran stands for formula translation. Fortran stands for formula translation. In order to execute a Fortran program, so first of all, what you need to do is that load the Fortran compiler tape. First of all, load the Fortran compiler tape. Okay, physically you need to place that particular tape onto the machine. This is what is my meaning is. Load the, just anyone please concentrate on it. Okay, why operating system has been invented now, we are going to be moving around it. Okay. Okay, so first of all, you need to load the compiler tape. First of all, you need to load the compiler, physically load the compiler tape onto the machine, run the compiler. Second step, run the compiler. That implies whatever the software is there. Okay, that is compiler software is going to be copied into main memory. Step number 3, unload the compiler, remove the tape from the tape drive. So, okay, first one, load the compiler, run the compiler, unload the compiler. Number next, okay, step number 4, run the assembly. So now today we are having assembler and compiler both are integrated on a single program. In earlier days, assembler is separate and the compiler is separate. So your compiler is only responsible for converting high-level language program into assembly language. Okay, assembly language. And after that, you need to supply that assembly language program to assembler, which is going to be responsible for converting into machine language. Okay, when you suppose already, I know that okay, you're all gate prepared student. Already you have been completed your compiler design subject. In compiler design, you have been seen as 7 phases like skill analysis, syntax analysis, interpretation, optimization, code generation, assembly and output, something storage assignment, assembly and output, 7 phases. Whatever the phases you are going to be seeing in your textbook, it's simply used to convert high-level language program into assembly language. In 7th phase only, you are converting assembly language program into machine language. Okay, now, so next one. So in order to run a job, in order to run a process program, first of all, load the compiler, run the compiler, unload the compiler. Load the assembler, run the assembler, unload the assembler. Then, now software is ready. Then the last 7th step is that load the object program and run the object program. This is the 8 steps you need to take. First of all, step number 1, load the compiler. Step number 2, run the compiler. Step number 3, unload the compiler. Okay, load the assembler, run the assembler, unload the assembler, load your object program and run your object program. These are the 8 steps what you need to do. These are the 8 steps what you need to do in order to execute a particular program. The time it will going to be taken for running these 8 programs, the 8 steps, the time it will going to be taken for running This 8 steps is going to be called as job setup time. The time it will going to be taken for executing these 8 steps is going to be called as job setup time. Then one scientist has been observed a very clear and a beautiful point is that, oh, what is a CPU? A CPU is very extremely fast device. It can having a capability of executing millions of instructions for a small fraction of a second. But due to the transaction of loading and unloading the tape, the CPU has been sitting the most of the time idle. Okay. Again, one scientist has been observed a very clear point is that, oh, what is a CPU? A CPU is a very extremely fast device. It can having a capability of executing millions of instructions for a small fraction second. But due to the transaction of loading and unloading the tape, the CPU has been sitting the most of the time idle. So how can you work on this particular idleness? Come on. And the research has been started. Oh, what is this? Okay, there is CPU is having a capability of executing millions of instructions in a small fraction second, but due to the transaction of loading and unloading the CPU has been sitting the most of the time idle. Okay, how can you overcome this idleness? Now there is a lot of research is going on. Now, next one, in order to make the CPU busy, come on, do something, come on, do something, and then the research has been done. Now, coming to the next one, in order to make the CPU busy, the next very important concept has been invented is simple batch systems. The next concept has been developed is simple one. So far, there is no operating system has been defined. Okay, so simply their aim is to how to keep the busy, how to keep the CPU busy at all the times. This is the only aim what they're having at the stage. Now, one scientist has been invented. One beautiful concept is for it as resident monitor system. Okay, it really says that this resident monitor system later on it is renamed as operating system. Okay, resident monitor system. The word itself it says that it is always resident in memory. It is always resident in memory. So coming to the first very important one is simple batch systems. Okay, under this simple batch systems, we are going to see two topics. That is number one, resident monitor system. Number two, the overlap of CPU and IO operations. We'll see. And coming to the first one. Now, okay, how do you keep the CPU busy at all the times? How do you keep the CPU busy at all the times? So now, okay, there are two solutions of job setup time. Okay, to reduce the job setup time. There is two solutions has been went in the market for reducing the job setup time. So what is that particular solutions? So coming to the first solution is that a professional computer operator was hired. The professional operator was hired. Why? Because the operator having a lot of experience on loading and unloading the tapes, and during the execution of the programs, in case if any error is encountered, he is going to do very fast, so that we can reduce the idleness of the CPU. Of course, it is not a very a good solution. Okay, acceptable solution. Okay, a professional is always a professional, and non-professional is always a non-professional. And coming to another one has been given a very good example. Okay, is that okay? Second major, how do you reduce the time saving? Small history, how in earlier, okay, the programmers are running the program. Okay, in order to run the program, earlier the people are coming to the computer science department, or may call it as the lab. So they are writing the entire program on punched cards. After writing this entire program on punched cards, okay, they are going to that all punched cards are going to be bundled and handed to operator. Okay, then operator will going to be sit in the evening. Okay, and he is going to run every program, and whatever the information which is displayed on the console, which lights has been displayed, these all lights are going to be written on a piece of paper and put it on that particular bunch of cards. The next day, the user will come and see, oh, what is how earlier I have been done like this. Okay, then again they have been rewritten the program. Let us take an example. Suppose you are written a program. Suppose you forgot to put a semicolon. The next day you will come and see, oh, I have forgotten to put a semicolon. The next day, I have been not put in one end. So that again, so in order to enter, there is no direct interactive editing process while running a program in earlier stage. This is what happened. So after submitting these all users are submitting programs after writing, they are going to submit it to operator. What operator is doing is that at the evening, okay, the operator first of all he picks. So suppose let us take user one damn C program, user two a Fortran program, user three something C++, user four something C, user five Fortran. Like this, the users has been given the program. Suppose the first program user one is Fortran, let us take. In order to run a Fortran program, what you need to do? First of all, he has to load the Fortran compiler tape, run the compiler, unload the compiler, load the assembler, run the assembler, unload the assembler, load your program, run the program. These are the 8 steps. Second program is, let us take user 2 C program. Well, again, what you need to do? Again, you need to load the C compiler, run the compiler, unload the C compiler. Load the C assembler, run the assembler, unload the assembler. Load the C program and run the job setup time. Listen, similar jobs are batched together in order to reduce the job setup time. In similar jobs are batched together in order to reduce the job setup time. So what the user will going to be doing in the evening is that, okay, whatever the programs which has been submitted to the operator will simply sort all the programs, all Fortran programs together, all C programs together, all other programs together like this. Okay, suppose if there is a 3 Fortran programs are there, then what he is to do is that first Fortran program is going to be run by using the step. In order to run the second Fortran program, no need to load again compiler tape and assembler tape. They are already there in main memory. Yes, simply you have to remove the last 2 steps, that is unload your object program and load your second program and run it. And that implies totally 6 steps of the time is going to be reduced. Totally how many steps are going to be reduced? 6 steps are reduced. That is going to be called as batch systems, and this kind of a concept is referred as batch system. Similar jobs are batched together in order to reduce job setup time. In order to reduce the job setup time. That's it. Either than another guy came and he simply says that, okay, what happens? Okay, when you are unloading a program and loading a new program, in that time, again the CPU is going to be sitting idle. Okay, again the people are not satisfied. Okay, what happens? Okay, during and you have been saved 6 steps of time. There is no problem. But what happens when you unload an executed program and loading a new program? The CPU is again sitting idle. How can you overcome this? Then they have been invented another new concept is known as resident monitor system. It is a resident monitor system. Then what the user says that another scientist has been said that, so whatever the programs which is there, what are the set of programs you are there, you please try to load all the programs in user program area. Suppose your user program area can accommodate 5 programs at a time. Then load all 5 programs at a time. Then first execute the first program and again remove it. And while removing, you please don't try to wait. Another program is already there in memory. Then execute the second program. In this time, what your monitor will going to do is the resident monitor bring another program in first program which is removed area. And after executing second program, again the CPU is going to move the third one. Okay, and your monitor will be responsible for removing the second program. In that, you are going to bring another new program. That implies simultaneously the programs are executed and programs are going to be bringing into main memory. Yeah, very good solution. Now, sir, what is the resident monitor system? Sir, what is resident monitor system? A resident monitor system is simply, it is a collection of 3 components. A resident monitor system is simply, it is a collection of 3 components. Resident monitor system is simply, it is a collection of 3 components. It is a collection of 3 components. Number 1, loader. So what is a loader? A loader is simply responsible for loading which takes a machine language program as an input and load that particular program into main memory. A loader is a small program which is responsible for loading machine language program from secondary storage device to main memory. A loader is a program which takes your machine language programs from secondary storage device and load that particular programs into main memory and preparing for execution. Preparing for execution in the sense, please try to set the starting address of the program to program counter for initiation of execution. Please try to set the starting address of the program to program counter for initiation of execution. This is the first component of resident monitor system. And second component is job sequencing. Okay, there are multiple jobs are there in the user programming area. Okay, so which job is going to be executed first and which job is going to be executed next? This is going to be decided by job sequencer. Okay, a job sequencer is a program which is a small program which is responsible for deciding which program is going to be executed in the next. And coming to the third very important one is the control card interpreter. This is the main program. Okay, control card and whatever the commands you are going to be entered by the user, which is interpreted and executed by the CPU. Okay, the simple job as control card interpreter is get the next command and execute it. Okay, so these are key collection of components is going to be called as monitor. Okay, this is a resident monitor system. Now the main disadvantage of this resident monitor system is that during the process of unloading an executed program, loading a new program in the particular time, again the CPU has been sitting the most of the time idle. Again, the people are not satisfied, okay, with this resident monitor system. Why? Because okay, during the transaction of unloading an executed program and loading a new program, again the CPU is going to be sitting the most of the time idle. In order to work on this particular idleness, next we have been entered into a new concept is going to be called as overlapped CPU idle operations. Then the people are thinking. The people are thinking. The people are thinking. The people are thinking that okay, so CPU is having a capability of executing millions of instructions for a small fraction of a second. And CPU is having a capability of executing millions of instructions for a small fraction of a second. But due to the transaction of input and output operation, due to the transaction of loading and unloading the tape, the CPU has been sitting the most of the time idle. Now we need to invent a devices in such a way that can supply okay millions of instructions to the CPU and okay millions of instructions to the CPU. Now, so earlier people are going to be completely writing the programs in okay punched cards. These all punched cards are going to be put it on card reader. Okay, the CPU is going to read information from the card reader and execute it. And after whatever the output is going to be got, this output is going to be okay directly copied onto your consoles or in the form of lights or may going to be have line printers. Okay, the output is going to be displayed on line printers. The output is displayed on line printers. Now here you can observe it. The CPU speed is completely depends upon card readers and line printers. The CPU speed is completely depends on the CPU speed is completely depends upon card readers and line printers. Okay, and after that the people has been invented tape drives. Okay, this kind of a concept where the CPU is going to be CPU speed is completely depends on card readers and line printers, which is called it as offline processing. And later on, okay, they have been invented tape drives. Later on, they have been invented tape drives. Tape drives are working more faster than card readers. Tape drives are, you have to note this point, tape drives are working more faster than tape drives. But the nature of the tape drives is that they are only sequential access devices. They are going to be sequential access devices. Sequential access devices in the sense where you can read line by line, etc. You cannot move on to randomly a particular position. That's enough. And so the second disadvantage of this tape drive is that okay, you can do only one job at a time. Okay, the tape drive cannot have the capability of doing 3 or 4 jobs at the same time. Okay, now so coming to the next one. Okay, they have been invented
and they are thinking that okay, we need to supply a more number of instructions for a small fraction of a second to CPU so that we can keep the CPU busy. And they have been invented the tape drive. So what is this particular tape drive? Tape drive is working more fast than card reader. So whenever the user is trying to execute any particular program, first of all, whatever the information that is there on the card readers, this information is first of all okay, you copied in card readers. From the card readers, this information is going to be copied on tape drives. Then CPU will going to be simply takes that information from the tape drive and execute it. Okay, CPU will receive that information from the tape drive and execute it. And whatever the output is got, okay, the output is not directly copied onto line printer. It is again transferred to tape drive. From the tape drive, again that information is going to be transferred to line printer. Now here you can observe that the CPU speed is completely depends on tape drives. CPU speed is completely depends on tape drive. That implies, but tape drives are working more faster than card reader, so that we can reduce the idleness of the CPU. Okay, somewhat, okay. Again, the people are not feeling comfort by using tape drives. Now we have been entered into a new storage device came into the market, which is going to be called as hard disk. Okay, we are going to be considering a new technique is going to be called as new storage device, which can having a capability of storing gigabytes of information. And the basic properties of hard disk is that first one, it stores a large amounts of information. Of course, tapes also store a large amounts of information. Okay, and hard disk is having a very good property is that it is a random access device. Additional property what we have with the hard disk is that random access device. Random access in the sense so you can access anywhere of the hard disk at the same time. You can access any piece of information on the hard disk at a time. That is hard disk. And coming to the second very important is that a hard disk can be allow you multiple operations at the same time. Hard disk can allow you multiple operations at the same time. Well, what do you mean by multiple operation? Okay, and you can do more than one operation at the same time. What is the meaning of this? Okay, you can read information from one particular place. You can copy the information in another place. You can move the content from one place to another. Simultaneously, it can allow you multiple operations on the hard disk. Okay, already everyone you are aware that how hard disk is physically adjust. A hard disk is internally having a spindle. A spindle is a collection of platters. You may get a problems on this. A platter is a collection of two surfaces. Each surface is divided into number of tracks. Each track is divided into either block or may call it as sectors. Okay, a sector is the smallest representable unit on a secondary storage device. The sector size is 512 bytes. Collection of sectors is equal to one block. Collection of blocks is equal to one track. Collection of tracks is equal to one surface. Two surfaces is equal to one platter. The collection of platters is equal to your hard disk. You may get a question like this. Okay, how do you get? In order to store one record, you require this number of bytes. Okay, the hard disk capacity is like this. So can you tell me how many number of platters is required? You may get a question like this. Okay, this type of questions, there is no formulas are there. You can know the theory concept, then only you can do it. So sector, collection of sectors is equal to block. A block is a collection of blocks is equal to track. A collection of tracks is equal to surface. A collection of two surfaces is equal to one platter. Collection of platters is equal to hard disk. This is what is this one. So the hard disk is having two kinds of additional features. Number one, random access nature. Number two, simultaneous peripheral operations. Simultaneous peripheral operations. Simultaneously execute multiple operations at the same time. And the third very important property with the hard disk is that hard disk is more faster than tape drive. Hard disk is, the very, very important one is, hard disk is more faster than tape drive. Hard disk is more faster than tape drive. So now, the people are going to be now, whenever the user is trying to execute any particular program, first of all, the information is going to be taken from card reader and it is copied in hard disk. From the hard disk, the CPU will receive this information and executed by CPU, and whatever the output is that is got, the output is going to be transferred to again hard disk. From the hard disk, the output is again copied back onto line. Again, now you can observe in this, the CPU is completely reading and writing information from the hard disk only. That implies, okay, the CPU speed is completely depends on only hard disk. but hard disk is working more faster than tape drive, so that I can conclude that okay, the idleness of the CPU has been reduced. Just 1 minute, why it has been stopped? Sorry for the inconvenience. Due to some pressing, the screen has been gone. Again, we'll come back. Okay, now the CPU speed is completely depends on hard disk. Okay, that's why this kind of an effect is going to be called it as spooling. Spooling stands for simultaneous peripherals operation online. Simultaneous peripherals operation online. Okay. And then finally, they have been concluded that, oh, what is this? You know, what is the speed of a CPU? The time it will going to be taken for loading one program in main memory. In that particular time, the CPU can having a capability of executing all the programs in memory. That is the speed of CPU. Okay, what is this? The time is going to be taken for loading one program in that particular program, in that particular time, the CPU can having a capability of executing all the programs in memory. That is the speed of CPU. Then they have been comes with a conclusion that sorry, we cannot catch up the speed of CPU. Finally, they have been comes with a new conclusion. Okay, CPU is very extremely fast device. It can having a capability of executing millions of instructions for a small fraction of second. We cannot catch up the speed of CPU. In order to make the CPU busy at all the times, in order to keep the CPU busy at all the times, we require something. We require something. Okay, we cannot invent any device that can catch up the speed of. We cannot invent any kind of IO device that catch up the speed of CPU. Then they have been, in order to increase the speed of an execution, in order to control the execution behavior of the CPU, we required something. What is the something? That is called it as operating system. Then, okay, they have been forgotten about, okay, they have been invented some tools. Okay, what is the particular tool? Okay, how to reduce the speed mismatch between CPU and IO devices, which can be done by using IO organization, which you can learn in computer organization. How can you reduce the speed mismatch between CPU and memory, which can be done by using memory interleaving concept, which is also done in your computer organization. Okay, so but finally they have been concluded that sorry, we cannot catch up the speed of CPU. In order to control the execution behavior of the CPU, something we required. Okay, what is that something? And that is they have been defined it as the operating system. Now completely, okay, we have got one question in GATE in earlier days. Maybe after before 10 years we get one bit. Okay, they have been given choices like this. In okay, A, B, C, something they have been given. Okay, in A, they have been given a point, offline processing, B, online processing, C, spooling, and right side they have been given 1, 2, 3. Okay, offline in the sense the CPU speed is depends on card reader. Online in the sense CPU speed depends on tape price. Okay, CPU speed depends on hard disk. They have been given like this. Match the following. They have been given this question. A small. It earlier. Okay, you are not going to be getting such kind of an easy questions right now. Now, why? Because everyone knows this kind of concepts. Okay. Now, finally, they have been concluded that sorry, we cannot reduce the speed mismatch between CPU and IO devices, and we cannot reduce the speed mismatch between CPU and memory. Some up to some level we can reduce it, but beyond that level we cannot do it. Then, in order to control the execution of the CPU, in order to utilize the CPU in very efficient manner, required some new concept is going to be required. Then they have been thinking that some new concepts are going to be required. Then they have been, one scientist has been invented a beautiful concept, a beautiful, you're always thinking about
You're always thinking about how to reduce the speed mismatch between, okay, you're always thinking about how to reduce the speed mismatch between CPU and IO devices and CPU and memory. Why can't you thinking about, okay, the idleness of the CPU during input and output operations? Okay, now we have been entered into a new concept. So what is this one? Suppose let us take an example. Suppose you are running a C program. So in that particular C program, okay, you have been okay, in the while running this particular C program, you got one statement: scanf percentage d ampersand a. What is this particular statement? Okay, you have to read one value from the keyboard. The value is of type integer. The value has to be stored in a memory location A. Okay, so this value has to be read from the user. In order to enter that number, how much time the user will going to be take? At least 1 second or 2 seconds. Why? Because the user has to be physically entered the number from the keyboard. It is a mechanical operation which should be received by your CPU in the form of signal, and it has to be decoded and processed and this one. Okay, now during this input time, at least in order to enter that number, the user will going to be taking at least 1 second or 2 seconds of time. In that particular time, the CPU has been sitting the most of the time idle. They have been invented beautiful. You are always thinking about only how to reduce the idleness of the CPU by means of IO and by means of memory. Why can't you thinking about in terms of programs? The programs is are uncontrolled. Our controls. Can you reduce this one so that we can reduce the idleness of the CPU? Then they have been told that during the transaction, while running a program, during the transaction of input and output operations, okay, the CPU has been sitting the most of the time idle. Okay, how can you work on this one? After then, one scientist has been invented a very good concept is going to be called as multi-programmed batch systems. Okay, this is going to be in your textbooks. You're going to be find out in the name of multi-programmed batch system. We simply call it as multi-program. So, what is multi-program? Here, everyone understood that what is input output operations. So what is input output operations in the sense, okay, printf, scanf, these kind of statements are going to be called as input output statements. That implies while executing separate statements, it will need an interaction with input output devices. That is what is going to be called as IO operations. Okay, and now coming to this one, what is multi-programming? Multi-programming in the sense, can you see on the diagram? I have been put it for. You know that the basic concept is that whenever the user is trying to execute any particular program, first of all, the program should be copied into main memory. Whenever the user is trying to execute any particular program, first of all, the program should be copied into main memory. Once a program is copied in main memory, it is not called it as a program, it is called it as a process. We'll see that kind of a discussion in a later stage. Now, so can you observe in this diagram, you found 4 programs. Okay, I can call at the present, I can call program or process, both are same. Okay, there are 4 programs are resident in memory. There are 4 programs are resident in memory. So now we'll define what is multi-program. More than one program can be simultaneously reside in main memory. During the execution of one program, if any program requires an IO operation, the CPU does not sit idle. It simply switches from one job to another job. Okay, while executing the second job, in case that job is also requires an IO operation, the CPU does not sit idle. It simply switches to some other job. While executing the third job, while executing the third job, in case the old stopped process has been completed IO operation, the CPU stop the present execution and give the control of the CPU to the old stopped process. Like this interleaved fashion of execution, giving a look and feel that all the jobs are going to be happening simultaneously. This kind of a concept is going to be called as multi-programming. This kind of a concept is going to be called as multi-programming. So simply it is defined as interleaved fashion of execution. Interleaved fashion of execution, giving a look and feel that all the jobs are going to be happening simultaneously. Let us take an example. Okay, I have been placed 4 processes in memory while executing first program. Okay, now I got one statement, printf, enter the number. Okay, so the user is not entered that particular number. During this particular time, what I can do is that simply I can switch this to process 2 while executing this particular program. In case this program is also need a communication with an IO device. Again, the CPU does not sit idle, it simply switches to process 3. Now, while executing process 3, suppose if the number is entered by user, what happens is that CPU Okay, simply switches from process 3 to process 1. Why? Because the old stop the process always gets a first priority. The old stop the process gets a first priority. An outside user can thinking that only one body, all programs are running simultaneously, but there is only one program is running. It is giving a look and feel that all the programs are running simultaneously. This kind of a concept is going to be called it as multi-programming. So multi-program in sense, more than one program can be simultaneously reside in main memory during the execution of one program. In case if any program requires an IO operation, the CPU does not sit idle. Okay, simply it switches from one particular process to another process. Okay, while executing the second process, in case that is also requires an IO operation, CPU does not sit idle. It simply switches from that job to another job. In case while executing third job, in case the whole stop to process has been completed IO operation, the CPU stops the present execution and giving the control of the CPU to the whole stop to process. Like this, the interleaved passion of execution, the look and feel that all the jobs are happening simultaneously. This kind of a concept is going to be called as multi-programming. You may get a doubt. Okay, while executing process 1, whenever an IO operation is encountered, you are switching from process 1 to process 2. Then whatever the input which has been given by user, who is going to be taken it? Okay, every computer system is having minimum two processors. Every computer system is having minimum two processors. Number one, CPU. Second one is IO. The CPU is responsible for executing arithmetic and logical instructions, and IO processor is responsible for executing input and output operations. IO processor is responsible for executing input and output operation. So while executing process 1, whenever an IO operation is encountered, the job is going to be handed out to IO processor. The CPU is going to do the second job. Like this, everyone. Okay, the communication between CPU and IO processor is going to be called as IO organization, which is already dealt in your computer organization subject, which is already dealt in, which is already dealt in, which is already just a matter. It is already dealt in your computer organization. This is multi-brand. That implies there is a lot of communication coordinate activities must be performed between CPU and IO processor, which is going to be called as IO organization. You are getting one. Okay, earlier gate we got one question. Okay, okay. How do you reduce? Okay, the communication between CPU and IO processor is known as what? That is IO organization. Now, coming to the detailed discussion about multi-programmed batch systems. Okay, this is what is multi-programming. Simply, you can define it as interleaved fashion of execution, giving a look and feel that all the jobs are going to be happening simultaneously. So, in order to understand, I'll give you a non-technical example for you for a better understanding. Suppose let us take an example. In your principal office, let us assume that your principal is the CPU. Let us assume in principal office is going to be called as main memory. Principal office is known as principal room is called as main memory, and principal is going to be called as CPU. And there are 4 persons sitting before the principal, and they are ready to talk with the principal. That is that 4 persons are going to be called as processes. Let us assume. Now CPU principal is now talking with one person, ask him to fill up the form. So whether principal is going to be sitting idle or whether principal is talking with any one of the other 3 persons? No, principal is not sitting idle. Simply principal is going to be switches to some another person and he'll talk it. Okay, now once this particular first person has been finished his process, simply he gives an interrupt. Sir, the task is done. You know what is an interrupt? An interrupt is nothing but it is a signal received by the CPU indicating that one external IO unit want to communicate with CPU. What principal is does that? Stop talking with the second person and giving the response to first person. Why? Because the first person, the whole stop to process always gives a first priority. Okay, an outside person, outside the room, one person is waiting. He is thinking that, oh, principal is talking with all 4 persons at a time. No, principal is not talking with all 4 persons at a time. He is giving a look and feel that he is doing all 4 jobs at a time. Interleaved fashion of execution, giving a look and feel that all the jobs are going to be happening simultaneously. This kind of a process is going to be called as multi-programming. This kind of a process is going to be known as Multi-programming. Now, what are the various technical words in multi-program batch system? Let us take job pool. Now, these are the technical words what we need to learn in multi-programming. What is a job pool? The set of all jobs which are resides in secondary storage device which is ready to come into main memory. What is a job pool? A job pool is simply defined as the set of jobs which are reside in secondary storage device which is ready to come into main memory. But if okay, your main memory is not having a capability of holding all the jobs in main memory. Okay, main memory is having only some space. Then what you're going to do? You are selecting some of the jobs from secondary storage device and copy into main memory. Who is that guy? That is done by job scheduler. A job scheduler is a small program which is responsible for selecting some of the jobs from secondary storage device and copy that particular programs into main memory Now, and after that, the set of all jobs which are resident in memory, we are going to be called it as a ready queue. The set of all jobs which are resident in memory and ready for execution is going to be called it as a ready queue. So ready in the sense, the word means that it is ready for CPU. It is waiting for CPU. The CPU has to be immediately come and execute it. That is a ready queue. But your CPU is not having a capability of executing all the jobs in a queue at the same time. The CPU can having a capability of executing only one job at a time. Then, among all these particular 4 jobs in memory, which job is going to be executed first, which is decided by process scheduler. Okay, we'll see the difference between job and a process or a program and a process. We'll see at a later stage, don't worry. Until it is resides on secondary storage device, it is called it as a job or may call it as program. Once it is came into the memory, it is going to be called it as process. What is the difference between program and a process? We are going to say. You can observe from my technical discussion, a program or a job is resides in secondary storage device, and process is going to reside in main memory. Process is going to reside in main memory. Now, process scheduler. This is what is process scheduler. So, process scheduler is responsible for selecting one job and executed by the CPU. Which job is going to execute the CPU first? Let us take an example. In order to meet your principal, 20 people are came at a time. Okay, your gatekeeper will going to be allow you all the 20 people into principal chamber at the same time. No, your gatekeeper allow you only 4 or 5 persons into the principal room at a time. The 20 people are going to be called it as job pool. Your gatekeeper or may call it as a peon is going to be called as job scheduler. He is responsible for selecting only 5 people and asking to get into the principal room. Principal room is called as main memory. Principal room is going to be called as main memory. That is ready queue. Now 5 people are waiting for the principal at a time. Your principal is not having a capability of talking with all 5 people at a time. So principal has to decide that okay, I need to execute first this one, second this one, third this one, depending on priority. Then it is decided by process scheduler. Okay, process scheduler is a program. Okay, which is decided which is going to be executed. Now, next very important concept is disk storage. If all 4 people are trying to store the data onto the hard disk at the same time, your hard disk is having a capability of storing all the jobs at the same time. The hard disk is simultaneous peripherals operation online. I can agree with that. But all the people are trying to throw the data on the same surface at a time. Each surface is having only one read ahead. Using one read ahead, you can do only one job at a time. If all 4 people are trying to throw the data on the same surface, it is not possible. Then your disk scheduling algorithms are decided that which job is first and which job is second, which job is third, and this is decided. Now, I'm coming to the last one is going to be called as in multi-program batch systems, memory management. What is memory management? Okay, I'm telling that a very important point is that whenever the user is trying to execute any particular program, first of all, the program should be copied into main memory. Whenever the user is trying to execute any particular program, first of all, the program should be copied into main memory. I'm clearly telling that the program should be copied in main memory. In main memory, where you are going to be copying your program, wherever the space is available, you need to copy there.
So how do you know that where the space is available, where the space is not available? Okay, this is decided by memory management. So a memory management program is responsible for keep track of which parts of the memory is full and which parts of the memory is empty. Okay, that is done by memory management. That is done by memory management. That is done by memory management. Okay, these are the different ones. Son, this is a very good one. Okay, now we are thinking about, okay, during input and output operation, the CPU has been sitting for most of the time idle. In order to overcome this idleness, we have been invented multi-programming concept. Okay, this is very good, a very nice concept, and very successful. Okay, now the my market we are going to refer these operating systems as multi-programmed operating systems, or we call it as multi-programmed batch systems. Then one scientist has been observed a very beautiful point, is that, okay, your, okay, while again the CPU is going to be wasting so many CPU cycles for deciding which job executed next. So what you done in the multi-programming? Well, executed one program. In case if any IO operation is encountered, the CPU does not sit idle. It simply switches from one particular job to another job. So another in the sense, which job you need to execute it. You need to decide who is having the high priority. The high priority job must be always executed first. High priority. High priority. High priority job is always executed. High priority job is executed always first. So, that is visible to everyone. Anyone is responding? Now continue. Okay, now one scientist has been invented a very beautiful point, is that, okay, the CPU time is simply wasting for picking who is having high priority. So what is this? Okay, so while executing process one, an IO operation is unwanted. I need to switch for either 2 or 3 or 4. Which I need to? Who is having high priority? The high priority has to be designed always first. How can I decide high priority? These all priorities are going to be there in interrupt vector table, or may call it as, you may at present you don't know what is interrupt vector table. We'll see at a later stage. Okay, in process table we have each and every process having some priority. So when I need to see that the priority of each and every process, and I need to decide which process has to be executed first. Okay, now then one scientist has been told that the time it will going to be taken for picking who is having high priority, in that time the CPU is having a capability of executing all the jobs in a time. What is this? The time it will going to be taken for picking who is having high priority, in that particular time the CPU is having the capability of clearing all the jobs in memory. The CPU is working that much of faster. The CPU is working that much of faster. What is this, sir? What is this point? Now let us see. If A greater than B, execute statement 1, else statement 2. You are written a statement like this. If A greater than B, execute statement 1, else execute statement 2. A greater than B, the time it will going to be taken for making one comparison, that is A greater than B. The time it will going to be taken for making one comparison. In the time, the CPU can having a capability of executing millions of computational statements, that is k is equal to k plus 10, I is equal to I by 10 by k. Like this kind of calculations can be done by your CPU, millions of calculations. Why, sir? Okay, why, sir, CPU is taking that much of time for making one comparison? Okay, why, sir, the CPU is going to be taking, okay, that much of time for making one comparison? One comparison. Let us take an example. What is a CPU? Everyone knows that a CPU is a collection of 3 components. A CPU is a collection of 3 components. Okay.
So CPU is a collection of three components. CPU is a collection of three components: arithmetic logic unit, number two control unit, number three memory unit. So memory unit is nothing but it is a collection of registers. Memory unit is a collection of registers. Okay, memory unit is a collection of registers. Number two, control unit, which is responsible for microprogram address sequencing. And CPU is a arithmetic logic unit is responsible for performing arithmetic and logical operation. Okay, arithmetic logical operations in the sense. Okay, so what are the different arithmetic operations is done by CPU? In the sense, the CPU can perform only one arithmetic operation, that is addition. So then how subtraction is done, how multiplication is done, how division is done. The subtraction is going to be done by using 2's complement or 1's complemented notation, complemented form. Multiplication, 2 5s are 10, that is 2 plus 2 plus 2 plus 2 plus 2. That is a repeated addition is nothing but multiplication. Okay, and next division, 10 by 2 is 5, 10 minus 2, 8 minus 2, 4 minus 6 minus 2, 4 minus 2, 2 minus 2. Repeated subtraction is nothing but division. Repeated subtraction is nothing but division. Repeated subtraction is nothing but division. The CPU performs only addition. CPU directly performs only addition. CPU doesn't know how to perform subtraction. It is done by using complementary notation. Multiplication is also defined in terms of addition. Division is defined in terms of subtraction. Subtraction is in terms of addition. Suppose if you want to calculate A greater than B, if you want to calculate A greater than B, first of all, what it does is that, okay, A is subtracted, okay, A minus B will perform, and that implies B is subtracted from A, sorry, A is subtracted, okay, from B, and after performing A minus B, then it says that whether the answer is positive or negative. If positive, A greater than B, if negative, A less than B, if it is equal to 0, A is equal to B. But what happens is that, how can you tell that whether it is a positive or a negative or is equal to 0? It depends upon the most significant bit. That is, most significant bit is 0. Okay, it may be a negative. If most significant bit is 1, it is positive. Then, in case if it is positive or negative, there is no problem. In case if it is positive or negative, there is no problem. In case if it is equal to 0, then what happens is that we need to check all the bits. Let us take in C language, integer occupies 2 bytes of memory. 2 bytes in the sense totally of 16 bits. Okay, that implies in case if it is 0, what happens is that 16 zeros. Okay, otherwise you can also have 1 followed by 15 zeros is also equivalent to 0. Actually, in normally we treat plus 0 and minus 0, both are same. But in computer science, plus 0 is different, minus 0 is different. We have two different types of representations for that. Okay, still we have such kind of a disadvantage in our computer system. Now, so in order to check whether all 15 elements are 0 or not, we need to connect with shift left register. Now, the shift left register is nothing but moving the bits towards the left. Register is nothing but a group of flip-flops. The time it will going to be taken for moving one bit of information from one flip-flop to another flip-flop is called as propagation delay. Now the time it will going to be taken for moving all these particular bits and compare with the 0 flag of your processor. And after compare, the time it will going to be doing all, subtraction is not directly done. First you need to perform addition, and after this complementary notation, after that you need to compare this all 15 bits. In order to make all this particular process, the CPU consumes a lot of time. In that particular time, the CPU can having a capability of executing millions of instructions. CPU is having the capability of executing millions of instructions. Now they have been comes with a new concept. Okay, so then they have been identified that okay, the CPU is going to be this kind of operating systems are called as multi-programmed operating systems. Now the people are going to be thinking that the CPU is going to be sitting the most of the time idle. Okay, for picking who is having high priority. That's why they have been come into a new type of operating systems is known as time sharing systems, which is also known as time shared operating systems, which is also known as time shared operating systems. What do you mean by this time sharing? Okay. Now, a single CPU is going to be shared by all the jobs at the same time. Time sharing systems were developed to provide interactive use of computer systems at a reasonable cost. At a reasonable cost. What is the meaning of this? Okay, what happens is that there is only one CPU will going to be shared by all the jobs. Each and every there are multiple dump terminals are there. Dump terminal in the sense those terminals which are not having any processing capability at all. And those terminals which are not having any processing capability at all. Each and every dump terminal is ready with one job. That is, let us see in the diagram, job 1, job 2, job 3, so on, and each and everyone treated as dump terminal. Each and everyone is going to be ready with one job. What CPU is going to be do is that CPU dedicates a small amount of time on job 1, and after the job 2, and again job 3, so on up to like this job n, again it will come back to job 1. Like this, CPU is going to be switching between all the jobs. And the CPU is going to be dedicates a small amount of time on each and every job. Within that particular stipulated amount of time, the job may be completed or may not be completed. Once the time limit is completed, the CPU simply switches from one job to the second job, next job, so on like this. Okay. So suppose in case suppose let us say how much amount of time which has been dedicated to execute each and every job is going to be called it as time quantum. How much amount of time it has been taken for executing each and every job is going to be called as time quantum. Okay, now suppose let us take an example. If job 1 requires 25 milliseconds, but the time quantum is only 10 milliseconds. What happens is that in first 10 milliseconds it executed, it again waits until for the next time slot, and again it waits for the next time slot. So after 3 times the job 1 is going to be completed. That implies that is either now that is which is going to be called as interactive use. And why it is used the word interactive? It is actually not interactive. No. It is an interactive use of computer. How CPU works, how speed the CPU works, you will see. Okay. Now, suppose you have been entered some number on the screen. Suppose 25. After entering that number, in order to enter that number and you will recognize that number is 25, how much time it will take? In that time, the CPU will going to be consumed and goes at least 10 times. The CPU works that time that much of faster. The CPU works that much of. Hello? So, is everything is going fine? That I'll let them, I'll confirm it. That's why I made a call. Okay, it's going fine? Yeah, fine, good. Okay, now that is job 1, job 2, so on up to like this. Okay. That implies each and every user while running a program, his program is running, and each and every user is thinking that I'm having my own processor. But really says that there is only one processor is going to be shared by all the guys at the same time. This is going to be called as time shared operating system. This is going to be called as a time shared operating system allows many users to share the computer simultaneously. That is a short CPU burst time. Each and every user is thinking that I'm having my own CPU. But a single CPU is going to be shared by all the users at the same time. A single CPU is going to be shared by all the users at the same time. So this kind of an operating system is going to be called as time shared operating system, which has been first introduced in Unix operating system. Actually, naturally, general way of defining different types of operating systems in the market is there are 3 types of operating systems. The people will talk: single user, single tasking operating system, single user multitasking operating system, and multi-user multitasking operating system. So let us see a small example for all this. Single user single tasking operating system. One user can operate it on a single CPU and he can do only one job at a time, only one process at a time. That is single user single tasking operating system. That is a single user single tasking operating system. Single user multitasking. Here the point is very clear. One user can operate on one CPU and do multiple tasks at the same time.
So coming to the first one, single user, single tasking. The best example is MS-DOS. The Microsoft Disk Operating System is the example for single user, single tasking. One user can operate on single CPU. He can do only one job at a time. Number two, the single user multitasking operating system. One user can sit on a one CPU and he can do multiple jobs at the same time. The best example is Windows. In Windows operating system, you can open multiple windows at the same time. You can do all the jobs at the same time. That's kind of a is going to be called as single user multitasking operating systems. And coming to the last one for discussion is that multi-user multitasking operating system. Multiple users can sit on a single CPU. Multiple users can sit on a single CPU and you can operate multiple tasks at the same time. So in Gate and multiple users can sit on a single CPU. You can do multiple operations at the same time. The best one is Unix operating system. Unix is a multi-user multitasking operating system. So in Gate, we have got one question is going to be called it as in multi-user multitasking operating system. Okay, how many minimum number of processors that is going to be required to run the 10 jobs at a time? They have been given 1, 10, 100, 200 something. The minimum number of processors that is going to be required to implement in multi-user multitasking operating system is only one processor. This is clear-cut question. Okay, that's it. So far, what operating systems we have been seeing? Okay, all operating systems are mainly used for keeping CPU busy at all the time. So what is a CPU? A CPU is very extremely fast device. It can having a capability of executing millions of instructions for a small fraction of a second, but due to the transaction of input and output operation, the CPU has been sitting the most of the time idle. In order to overcome such kind of an idleness, we have been introduced operating system. Operating system has been invented for the purpose of keeping CPU busy at all the time. The main duty of an operating system is that to keep the CPU busy at all the times. That is the main foremost thing. To keep the CPU busy at all the times, the operating system has been invented. So far, whatever the types of operating systems we have been seeing, that is multi-programmed operating systems, time-shared operating systems, simple batch systems like this, risk monitored, these are all used for keeping one CPU busy at all the times. Now we are entered into a new technology is going to be called as multi-processor systems. Then you may get a doubt, sir, in order to keep one CPU busy at all the time, we are struggling a lot. That's why we have been invented an operating system concept. Why we need to keep multiple CPUs on a single computer system? Earlier from the discussion, we have already understood that every computer system has minimum 2 processors, one is CPU, second one is IO processor. Suppose you have a good amount of money on your pocket, can you put a more number of CPUs on a single system? There is no problem. Your speed will going to be increases. There is no problem. Okay. Then what is the need of putting more number of CPUs on a single computer system? Okay, suppose you are not having any use at all, but we are having a lot of uses while constructing servers. Let us take an example. If you consider Google server, okay, how many people are going to be connected to Google server at the same time? Millions of users are going to be connected to your Google server at the same time. Okay, in case if the server is equipped with only one CPU, only one CPU is sufficient for servicing all the people at the same time. No, we need to get a more number of CPUs on a system. So in order to do such kind of a thing, okay, in order to provide multiple users to respond at the same time, okay, in order to implement internet servers, we require multi-processor systems. Now, whenever you have a multi-processor system, definitely you have multi-processor operating systems. Then you have, in order to keep a single CPU busy at all the times, you have an invented operating system. So in order to keep, so now we are keeping more number of CPUs in a single system. In order to make busy all the CPUs at the same time, you have multiple processor operating systems is required. That's why. Now coming to the first one, multi-processor systems. What is multi-processor? From the diagram you can see, okay, multiple CPUs are connected to a memory.
Yes, everyone can see. What is multi-processor system? More than one CPU can be simultaneously reside on a same mission. They are closer to communicate in order to establish the communication between the processors. If they're using same clock pulses, same buses, same memory, then such kind of a technology is going to be called as parallel system technology. So indeed, what is meant by multi-processor system? More than one CPU can be simultaneously reside on a same mission. They are closer to communicate. In order to establish the communication between the processors, if they're using same clock pulses, same buses, and same memory, then it is going to be called as parallel system technology. In order to establish the communication between the processors, if they're using separate clock pulses, separate buses, separate memory, then it is going to be called as distributed system technology. Then it is going to be called as distributed system technology. Now we're going to enter into the first topic of discussion is that parallel system technology. What is parallel system technology? Okay, so more than one CPU can be simultaneously reside on a same mission. They are closer to communicate. In order to establish the communication between the processors, if they're using same clock pulses, same buses, same memory, then it is going to be called as parallel system, which is also known as tightly coupled systems. It is also known as tightly coupled systems. What is the use? And let us say, okay, I'll tell you before going to the different kinds of advantages of this parallel system technology. I'll tell you for the user's point of view, for the student's point of view, I'll tell you a little bit example. Okay, let us, you'll take, suppose you take a 3 by 3 matrix addition. Suppose you have take two 3 by 3 matrices. Okay, in a computer system, you have only a single processor. Okay, only one processor. In order to perform one addition, it takes 1 microsecond. Let us take an example. Okay, it takes 1 microsecond. In order to perform all the 9 operations, it will take total amount of time is 9 micro operations. Suppose if you have 9 processor in your computer system, all 9 additions can be done in 1 microsecond. Why? Because the first one element is added by first processor, 1 2 element is added by second processor, 1 3 element is added by third processor. So similarly 2 1 2 2 3 3 3 3 4 4 3 1 3 2 3 3. Okay, that implies in a single processor system, in order to perform a 3 by 3, it will take 9 milliseconds of time. In case if a parallel system with equipped with 9 processors, it will take only 1 microsecond, only 1 millisecond is sufficient for executing all operation. That implies it improves. The first advantage is that it improves throughput. That implies more number of jobs that is completed on a given number of time. Throughput is nothing but simply defined as the number of jobs that is completed on a given unit of time. That is the first advantages of parallel system. Why it is named as tightly coupled? Tightly, that implies they are sharing same clock pulses, same buses, memory. There is always some, in order to manage all this particular thing, we require a special kind of software. That's why it is named as tightly coupled. The second advantage is that saving money. Suppose if you want to put a more number of CPUs, each and every CPU have a separate cabinet, separate motherboard, separate peripheral devices. It takes more amount of money. If all are integrated on a single board, it going to be less cost. And third very important one is the third advantage is that reliability. The third very important one is reliability. What do you mean by reliability? Okay, first of all, in order to understand this one, reliability. What is reliability in a sense? It should give a meaningful output for every possible combination of the scenario. You should give a meaningful output for every possible combination of the scenario. What is the meaning of this? Suppose the server is equipped with 10 processors. Now, if one processor is failed, what happens? The entire system server will going to be getting down? No. Okay, what happens is that which processor has been failed, that processor work is going to be shared by remaining all the 10 processors. And the overall speed will going to be reduced by 10%, but it continuously providing service for that. This kind of an ability is going to be called as graceful degradation. That implies the ability to continue providing service, the ability to continue providing service proportional to the level of non-failed hardware is going to be called as graceful degradation.
That implies even though if a processor is failed, the failed processor is going to be taken, work is going to make the rest of all the processors, and the system will not going to be down, and it is continuously working. Then such kind of a process is the concept is known as graceful degradation. In case if any software has been constructed with fail-soft softwares, such kind of a software is going to be called as in case if any software has been implemented using graceful degradation concept, such kind of a softwares are going to be called as fail-soft softwares. Now, these parallel systems, or may call it as this multi-process systems, are classified into two categories: symmetric multiprocessor organization, asymmetric multiprocessor organization. It is classified into symmetric multiprocessor organization, asymmetric multiprocessor organization. What do you mean by symmetric? If all the CPU of same type of configuration, if all the CPUs are the same type of configuration, that implies all Pentium 4. Suppose a server is equipped with 10 processors, all 10 processors are something i3, 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 all 10 are i3, then it is called as symmetric multiprocessor organization. All the processors are same configuration. Asymmetric, in the sense, one is i3, second one is i4, sorry, i5, one is i3, one is i5, one Pentium 4, one dual core, one core 2 duo. Like this, several processors integrated on a single system, then it is going to be called as asymmetric. Okay, symmetric in the sense all processors are having same configuration. Asymmetric in the sense there are different configurations. Now, this is going to be called as parallel system technology. The second type of multi-processor organization is the distributed system, which is also known as loosely coupled system. What is this? What is this loosely coupled system? So it is also a multi-processor organization. More than one in multi-processor organization, more than one CPU can be simultaneously reside on a same machine. They are closer to communicate. In order to establish the communication between the processors, if they are using separate clock pulses, separate buses, separate memory, then it is going to be called as this distributed system, or may call it as a loosely coupled system, or may call it as loosely coupled system. In a multi-processor organization, more than one CPU can be simultaneously reside on the same machine. They are closer to communicate. In order to establish the communication between the processors, they are using separate clock pulses, separate buses, separate memory, which is going to be called as a distributed system, or may call it as a loosely coupled system. Then what is the advantage of integrating all these systems on a single machine? Number one, first one, resource sharing. A remote system can directly access a resource that is connected anywhere in the network. Suppose let us take an example. The best example for a distributed system is that your local area network. In a local area network, in your observe in your college, there are several systems are connected in a LAN, but the printer is connected to only one system at the end. So if anyone want to take a printout, no need to go there and take a printout. You can sit in your system, and you can directly give a printout to that remote system, which can be possible by using only distributed systems only. That is resource sharing. Okay, a resource on the network can be shared from any place. That is remote sites. Number two, computation speed up. That is load sharing. We can also going to call it as this is load sharing. Is also going to be called as a load sharing. What do you mean by this load sharing? Suppose you have got one work. Suppose you need to copy, suppose you need to download 10 files from the internet. Suppose it is going to be happening on only one particular system at the same time. So it will take so much amount of time. Then why can't you distribute this work to all 10 systems which are there in every system, so that one system can download one file? That implies all the 10 files are going to be downloaded at the same time. That is computation speed up. A computation can be distributed to all the CPUs at the same time. If you want to take it technically, suppose let us take a file is having 100 records. I need to update each and every record. If one processor is there, if the processor is responsible for taking one record, make an updation, or I can take second record, make an updation. Like it will take so much amount of time. Now, if you take 10 processors at the same time, divide that particular file into segments. Each segment have 10
records. Now this 10 records is supplied to all 10 processors at the same time, so that the total file updation is going to be done in a short amount of time. That is computation speed up. The computation work will going to be divided into several processes. Number three, reliability. Just already you know that what is reliability. Just now I discussed. It should give a meaningful output for every possible combination of the input scenario. That implies in a network, if any one of the computer failed or a processor failed, the entire network will not going to be down at all. It is continuously providing services to all users at the same time. This kind of a concept is known as graceful degradation. If any software has been constructed by using graceful degradation, such kind of a concepts are going to be called it as fails of softwares. The main purpose of establishing distributed systems is their communication. Communication is nothing but simply it is a process of exchanging an information between any two systems. This is what is distributed system. Now, these two concepts are completely related to keeping multiple CPUs busy at all the times. Earlier, we have been saying multi-programmed and time-sharing operating systems are going to be used for keeping one CPU busy at all the times. Parallel systems and distributed systems are mainly used for keeping multiple. How we keep multiple CPUs at the same time, multiple GPUs busy at the same time. Now, coming to the last very important topic of discussion is that real-time operating system. Topic of discussion is real-time operating system. Okay. So instead of giving the definition of before going to the detailed discussion about the real-time operating system, first we know the example. This kind of learning is called as example-based learning. Okay, first we'll see the example, then you can understand what is basic definition. The operating systems especially used in embedded system related softwares. The operating systems especially used in embedded system related softwares is going to be called as the operating systems, which is especially used in embedded system related softwares, is going to be called as related real-time systems. Especially the electronic devices, what you're going to see in the market. These all electronic devices are going to use an operating system called it as real-time operating systems. Okay, what is this particular this one? Why? Because we given this example in the sense the critical task must be completed on given guaranteed amount of time, otherwise the system is going to be fail. That implies in case if any operating system has been defined with the principles of time constraints, then such kind of an operating systems are going to be called as real-time operating systems. In case if any operating systems has been in case if any operating system has been designed with the principles of time constraints, such kind of an operating systems are going to be called as real-time constraints. So let us take an example, a small example. For student convenience, I am giving this example. Okay, suppose if you went in ATM, suppose you haven't put in a card and you haven't enter the required amount of money what you require, then it makes some sound to counting the number of notes. After that, you did not get money. Then what is your feeling? Immediately you will get disturbed, and immediately you are pressing a lot of buttons. What happened? What happened? What happened? That's it. Then implies whatever the task which is specified there, it should be completed within stipulated amount of time. Otherwise, it will give you a message that the required time is out, the transaction is not processed, again re-entered it. Because that implies whatever the task has been specified. Let us say whatever the task you have been specified, that particular task must be completed on a given guaranteed amount of time, otherwise the time system will going to be failed. And such kind of a thing is going to be called it as a real-time operating system. So this is one example which is near to you. Now I'll give you a more technical example. This. Suppose let us take an example. The current whatever we are using we are using water current, or may call it as coal current, and that implies this current is generated from water, or may call it as by burning coal. We are getting this current. But in America, USA, United States of America uses nuclear current. They happen prepared a nuclear reactor. In that nuclear reactor, they're having two uranium rods are have been put in. Thus, uranium rods are going to be exposed a lot of ions at the same time. These explosion ions will going to be simply touched to the reactor walls, and there is produces a lot of ionic energy that is converted into mechanical, and mechanical energy is converted into electrical energy. How they are going to be getting this particular power? This is. But what happens is that nuclear reactor is very dangerous. That nuclear reactor must be, two rods must be working with the temperature of something, let us take an example, 75. If both are 75, then only it works. In case, if any unwanted reasons, or may call it as some temperature changes, okay, one is went to 76 or another one is went to 74 like this. Again, within 10 nanoseconds time, it should be bring it to 75. Otherwise, the reactor will going to be blast. Okay, the entire US will going to be smashed at a single time. So now whatever the task which has been specified there, the task must be completed within 10 nanoseconds of time, otherwise the system is going to be failed. So whatever the operating system which has been designed to control that nuclear reactor is going to be called as a real-time operating system. Okay, that's why we have been defined as okay, real-time operating system. The critical tasks must be completed on a given guaranteed amount of time, otherwise the system is going to be failed. In case if any operating system has been designed with time constraint, the such kind of an operating systems are going to be called as real-time operating systems. Now there are two flavors of real-time operating systems are there in the market. Number one is hard real-time system. Number two, soft real-time system. Now coming to the first one, hard real-time system. So far, what definition have been given to you? This definition is a hard real-time system. Now, soft real-time system. What is soft real-time system? Each and every job while submitting to the operating system, it specifies two things. Number one, how much amount of time that is required to complete the job, and what is its deadline. In soft real-time system, each and every job while submitting to the operating system, it specifies two things. Number one, how much amount of time that is required to complete the job, and what is it? How much amount of time it's going to be complete the job. Then CPU will going to be schedule each and every job in such a way that no job is going to be scheduled after its deadline. Like this, you are going to be okay, complete your task. This kind of an operating systems is going to be called as soft real-time systems. Let us take an example. Suppose I am the CPU. There are a lot of students who came in front of me for asking doubts, and one student came, sir, I have one doubt. In order to clarify that, it requires 5 minutes of time, but I need to leave here by 10 o'clock. And he specified that 5 minutes of time, and it has to leave by 10 o'clock. Another student is came, sir, in order to complete my clarify my doubts, it takes 10 minutes of time, but I need to leave this particular campus by 9:30. In worst Hello? Yeah, it is listening. Is it okay, everything? Hello? Is everything is properly recorded? I'm not getting your voice.